A small shoe manufacturer makes two styles of shoes, Oxfords and loafers. Two machines are used in the process, a cutting machine and a sewing machine. Each type of shoe requires 15 minutes per pair on the cutting machine. Oxfords require 10 minutes of sewing per pair, and loafers require 20 minutes of sewing per pair. Because the manufacturer can hire only one operator for each machine, each process is available for just 8 hours per day. If the profit is $15 on each pair of Oxfords and $20 on each pair of loafers, how many pairs of each type should be produced per day for maximum profit? This is an example of an optimization problem. Okay, optimization is when you are trying to either maximize some quantity or minimize it. Okay, find the very biggest it can be or the very smallest it can be, given a set of constraints. Okay, and these are all about systems of linear equations, systems of linear inequalities, really. So what we're going to do here is write an inequality for all the pieces of information, all the restrictions that we have. Okay, so we've got two restrictions here. Actually, we've got a sewing machine, and we've got a cutting machine. And we've got a restriction for both. And the restriction is the amount of time we can spend on them. Okay, and that amount of time is 8 hours. So the two unknown variables here are the number of pairs of Oxfords and of loafers. So we're going to go ahead and call those X and Y. So X will be the number of pairs of Oxfords, and Y will be the number of pairs of loafers. Okay. So now for our sewing machine, we've got a couple of pieces of information here. Oxfords, okay, require 10 minutes of sewing per pair. So 10 minutes, I'm going to do this all in terms of minutes, okay? So I've got 10 minutes per pair of Oxfords. So that's 10 times X. And then I've got, loafers, which require 20 minutes of sewing. So that's plus 20 times Y. This is the total number of minutes spent on sewing, and that has to be less than or equal to 8 hours, and 8 hours is 8 times 60 minutes, so that's 480 minutes. Okay, then I've got my cutting machine, and I know each type of shoe requires 15 minutes per pair. So that's going to be 15 times X plus 15 times Y, the total amount of time cutting. And the total amount of time cutting has to be less than or equal to, again, 8 hours, which is 480 minutes. So I've got this system here of inequalities. And because my variables represent physical quantities, we should probably indicate that X and Y both have to be greater than or equal to 0. Okay, the manufacturer cannot manufacture a negative number of pairs. So this here is our system of inequalities. Now there's one other thing here to look at, and that's profit. Okay, and this is something called the objective function. Okay, objective function. This is the thing that you were trying to optimize. So in this case, that's the profit. Okay, and that's $15 on each pair of Oxfords and 20 on each pair of loafers. So that's going to be 15 times X plus 20 times Y. This is my profit. So now what we're going to do is we're going to look at the feasible region for our system of inequalities. We have a really nice theorem that tells us that if we're trying to optimize a linear function and it is subject to linear inequality constraints, then the maximum or minimum of this has to occur at one of the vertices. Okay. So now what we do is we just plug those vertices into this function. So we're going to plug 0.24 in. Okay, and so that's 15 times 0 plus 20 times 24. Okay, and that is 480. We're going to plug 1616 into this. So 1616 is 15 times 16 plus 20 times 16. And that is 560. And then if we plug 32 0 in, we get 15 times 32 plus 20 times 0. And that is 480. And of course, if you plug 0 0 in, this one, of course, just, well, that's 15 times 0 plus 20 times 0, which is 0. So then you plug in all your vertices, and then if you're trying to maximize, which we are here, we want to get the maximum profit, we just find which number was the biggest. And that was this 560. And so that tells us that this 1616 was the amount of Oxfords and loafers to manufacture in order to maximize the profit.